Hey everyone, yesterday we talked about the empirical rule, which I sometimes just call the 689599.7 rule. Remember, it states that the normal distribution is fairly predictable when you're going 1, 2, and 3 standard deviations away from the mean. So just a little recap, the normal distribution is a mathematical model that statisticians use to describe distributions of a data that are approximately normal. It is symmetric, unimodal, and bell-shaped. And the graph is completely determined by two statistics. One is the mean, which would be right down the center, and the other is the standard deviation. I'm going to switch it around. Okay. Sorry, I'm going to write with the folder under. Okay, so the total area under the curve is always equal to 1, which corresponds to 100% of the values of the distribution. Okay, so let's revisit the Peyton Manning example from yesterday, where we used data for his first 176 games in his career, where he had a mean of 259 yards and a standard deviation of 74 yards. So, suppose we want to know what proportion of Manning's games had at most 100 passing yards. So, here we have a curve right here. Remember, the mean goes right down the center. That was the 259. And then, as we move to the right, we're adding one standard deviation. So, plus 74, plus 74, plus 74. And as we move to the left, away from the mean, we're subtracting one standard deviation. Now, yesterday, all of our values fell exactly 1, 2, or 3 standard deviations above or below the mean. But what about right here when we're talking about the 100? 100 falls right in between right here. It's between 2 and 3 standard deviations below the mean. So do we estimate it? What do we do? Well, we're going to use something called the standard normal table today. Okay, so normally yesterday we used 689599.7 when it fell exactly 1, 2, or 3 standard deviations away. Today we're not going to be that lucky. So it says, since the value does not fall exactly 1, 2, or 3 standard deviations from the mean, we'll use what's called the standard normal table to help. The standard normal table lists the proportion of values that are less than a given standardized score. Now remember, another word for standardized score is z-score. The standard normal distribution is the normal distribution with a mean of 0 and a standard deviation of 1. So today, you guys, we are going to use this table right here and to help us with solving these problems. So it says, estimate the proportion, so back to the original question, where we're estimating the proportion of games where Manning would have at most 100 yards. So it says, first we're going to want to find the z-score first. Okay, so at most 100. Let's try and figure out what this means. At most 100 means less than or equal to, okay, 100 or less. So we're going to try and find the probability or the proportion of X values for Peyton Manning that are less than or equal to 100 yards. So my first step is I want to find the z-score. So I'm going to go off to the side and find my z-score. Recall the formula for the z-score is your X value minus the mean divided by the standard deviation. So here our value is 100 minus the mean, which is from above 259, divided by the standard deviation, which is 74. So we're going to round our z-scores to the 100th, which is 2 decimal places. So when we type this in, we get negative 2.15. Sorry, negative 2.15. So that's our z-score, our work for our z-score. So now that we standardize the score, we're going to be able to use the standard normal table. We can't just use the table because the table has a list of z-scores. So we need to know, according to our data with our given mean or given standard deviation, how many standard deviations above or below the mean is this value, which is the z-score. So this corresponds to x changes to z, the probability that z is less than or equal to negative 2.15. So we are going to go on the standard normal table and make sure you are on the side with the negative z-scores. So go all the way to the left-hand column and look at z. Make sure you're on the side with the negative z-scores. Now, along that left-hand column, you're going to go down to negative 2.1. Then up top are all the hundredths places. Well, our hundredths place was 0.05. And then, so you're going to want to see where they cross. They cross at 0.0158. So that is equivalent to 0.0158. Or I'm fine if you write your answer as 1.58%. Either one works. Okay, which makes sense. Let's take a step back and look at this. If his average is 259 yards, estimate the proportion of games, or what's the probability he throws at most 100 yards, so he throws 100 or less? Well, considering his average is 259 with a standard deviation of 74, I'm expecting that not to happen very often at all. So yeah, less than 2% of the time. Okay, the next one. Find the proportion of games in which Manning would have at least 290 yards. So we're still using the same mean and standard deviation. So you need to ask yourself, what does at least mean? At least means greater than or equal to. So I'm going to try and find the probability that x is greater than or equal to 290. So my first step I want to do off to the side is find my z-score. Recalling from above that your mean was 259, your standard deviation was 74. So, whoops, sorry, we don't need to write the formula every time. 290 minus 259 divided by 74. Now this value is above the mean, so I'm expecting it to have a positive z-score. And remember, we're going to round our z-scores to the hundredth because that's what our standard normal table rounds to. And we get a z-score of about 0.42. So now x value is greater than or equal to 290. When I use the standard normal table, that corresponds to z-scores that are greater than or equal to 0.42. So this time, I'm going to be on the side with the positive z-scores. So I want to make sure positive z-scores right here, my z-score was 0.42, so that corresponds to 0.4, and then I go along the top to 0.02. Where does that cross? At 0.6628. Now, just to recap, earlier, remember we said that the standard normal table lists the proportion of values that are less than a given standardized score. And it's also shaded here. It shows you that the probabilities in this table, it's in the shaded region, so it's always what's less than the z-score. So keep in mind the 0.6628, this is your 0.6628 from your table. Okay, but we wanted at least 290, so we wanted this area right here. So if I know this is 0.6628, how do I figure out this value? Well, remember the whole curve is 1, so it's going to be 1 minus 0.6628, which gives us 0.3372, or 33.72%. I know it asks for proportion, which typically means this answer, but it could ask you for percentage as well in your test. Either one's fine. Now, the question we get a lot is, when do we use 1 minus? So keep in mind, the 1 minus, okay, is whenever you're looking for the right side of the curve. So a lot of times, question asks you for at least, because at least means bigger, greater than, or more than. All of these refer to finding the area where the value is bigger than a given data point. Okay? So, we can either word our questions like we did in letter B, letter C, or it's what I call an in-betweensy question for letter D. What proportion of games did Manning throw between 2 and 300 yards? So, for this one, we actually need to find two z-scores. So we're trying to find the probability that the x value is between 2 and 300 yards. So I'm going to find the z-score for 200. Remember, using the same mean and standard deviation. The mean was 259, the standard deviation was 74. And I'm going to find the z-score for 300 yards. So for my first one, for 200, I get about negative 0.80. And my next one, I get about 0.55. Okay. So 200 corresponds to the negative z-score because that's the one that's below average. Keep in mind for the in-between z questions, it's not always going to be, one's going to be a negative z-score, one's going to be a positive z-score. That's just how it worked out in this case. But the smaller z-score would come first. Okay? So essentially what we're going to do here for our table is we're going to find the area that's less than both of these values. So if I were to sketch a curve right here, we ultimately wanted to find the area in between both of these z-scores. So this area right here. This is ultimately what we want to find. So what am I going to look up on my table? Well, on my table, I'm going to look up the proportion that are less than 0.55. So that's going to give me all of this area though. Do I want all of that area? No, I only wanted what was in between these two values. So if I get everything less than this, I'm going to subtract away what's less than the smaller z-score. So I'm going to subtract away this area and I will get what's in the middle, which is what I want. So I'm going to look up 0.55 on my standard normal table first. So make sure you're on this side with the positive z-scores. So 0.5 and then 0.5 for the 100th. And I got 0.7088. Minus, now I'm going to switch because I have a negative z-score for the next one. So go down to negative 0.8, and it's negative 0.80, so it's your first number. So subtract 0.2199. I'm sorry, 0.2119. And then I'll get my answer, which is 0.4969. Or again, about 49.69%. Keep in mind, you guys, if you would have subtracted the other way, you'd have gotten a negative number, which wouldn't make sense. The proportion of times that Manning throws between -2 and -300 yards, it doesn't make sense to have a negative number. So it's always going to be your larger area minus your smaller area. Okay? So if you want, you can pause the video right now to try the your turn questions. If you don't want, you can work through them with me right now. It says, suppose the heights of college women follow a normal distribution, which is good. We need to see that in order to use the standard normal table, with a mean of 65 inches and a standard deviation of 2.7 inches. What proportion of college women are at most 60 inches tall? So we want to remember at most, 60 means 60 or less. So we're going to try and find the proportion that are less than or equal to 60. So my first step, I'm going to find the z-score for 60. I get negative 0.185. Now I'm going to use that probability that z is less than or equal to negative 1.85. So let's think about this. 60 inches tall, because we know a little bit about heights of females. 60 inches tall is 5 feet, is equivalent to 5 feet tall. So what's the probability that a college woman is at most 5 feet tall, or is 5 feet tall or less? I would think that number should be pretty low. So make sure you're on the side with the negative z-scores. Negative 1.8. Your hundredth is that, if you go over to your hundredths, 0.05. We get about 0.0322. Or about 3% of women. That makes sense, are less than 5 feet tall. So anytime you know you have like a little bit of background knowledge about the subject, it's always helpful because you can stop and analyze your answer to see if it actually makes sense. What proportion of college women are at least 69 inches tall? Well, at least means greater than or equal to, so the probability that x is greater than or equal to 69. 69 inches is equivalent to 5'9", so the probability that a college female is 5'9" or taller, I'm thinking this number should definitely be less than 25%, probably even less than maybe even 15% or 10%. So let's see. So find the z-score for 69. And you get about 1.48. Okay, so now I am going to find the probability that my z-score is greater than or equal to 1.48. So look at the side with the positive z-scores. On the left, you're going down to 1.4, and then you're going all the way over to 0.08, and you get 0.9306. 0.9306, you're telling me 93% of women are 5'9" or taller? Doesn't make sense. Remember, when you're doing an at least problem, you got to do the 1 minus. Okay? You got to do the 1 minus. So, because just to recap, right here, this 0.9306 is right here, but we want what's over here, so we got to do 1 minus. So it's going to be 1 minus 0.9306, which is about 6.94%, or about 0.0694. Now, what proportion of college women are between 60 and 72 inches tall? Well, let's think about it. 60 inches is 5 feet tall, 72 inches is 6 feet tall. What proportion of college females are between 5 and 6 feet tall? Well, I would expect this number to be pretty high. Remember, when it's an in-between z question, you gotta have 2 z-scores. So the probability that x is between 60 and 72. So I'm going to find my z-score for 60, which you actually already did above. And then my z-score for 72 again, this has a positive and negative z-score. It might not always turn out this way. So keep in mind, I know for a greater than question, it had a positive z-score, and the less than question had negative. It doesn't always turn out that way. It just happens to in these examples, you guys. So just make sure you're following what phrases they're using in the question to determine whether or not it's a greater than or less than, which determines whether or not you have to subtract your proportion from one or not from the table. So remember, I'm looking at negative 1.85. Oh, I probably should have drawn that a little bit farther over. And 2.59 for my z-scores. I want what's in the middle. And remember, in order to get what's in the middle right here, I got to figure out what's less than 2.59. So I'm going to look up 2.59 on my z-table. That's 0.9952. Minus, so I have all of this, but remember, I don't want all of this. I just want what's in the middle. So I'm going to subtract the proportion that's less than negative 1.85. So I'm going to look up negative 1.85. And I got 0.0322. And if I subtract this away, I'll get what's in the middle, which is what I want. So we get about 0.963. Which makes sense. I would expect a high number. About 96% of women college females are between 5 and 6 feet tall. That makes sense. So it says, suppose you are in a college class with 45 females. How many of these women would you expect to be between 60 and 72 inches tall? So it says, use your answer from part C. Well, we just found out that 96.3% of women, of college females, are between 5 and 6 feet tall. So it's going to be 0.963 times 45, which gives us about 43.335 females. Or if you just wrote about 43 females, that's fine. As long as you show your work, we're good. Okay? So, kind of to sum it all up from yesterday and today's lesson, when you see exactly 1, 2, or 3 standard deviations from the mean, or you're asked for the middle 68, 95, or 99.7% of the data, you're going to use the empirical rule, or the 68, what I call the 68, 95, 99.7 rule, or the empirical rule, however you refer to it. For all other problems, you guys, we're going to use the standard normal table. Or what we can call the z-table. So this is just a shortcut, okay? If you forget to use this rule, that's okay. This is just a long way, but this is a shortcut. Since these values are fairly predictable, we can come up with, that's how that rule came about. Okay, that concludes the Chapter 8 Topic 3 notes. Good luck on your assignment, guys. It's a worksheet.